Hello and welcome to Full Tech Ahead. I'm your host, Amanda Razani, and with me today I have the CEO of Ferric, Noah Sturcken. How are you doing?
Doing great. Yeah, thanks so much for having me, Amanda.
Happy to have you on the show. Can you share a little bit about yourself and Ferric?
Yeah, of course. So I'm Noah Sturcken. I'm one of the founders and the CEO of Ferric. We're a semiconductor technology company, founded and based in New York City. We also have operations in Silicon Valley and in Asia. Our company makes integrated voltage regulators. So these are power converters that have been miniaturized 10 to 50x relative the size of conventional power converters. And so here's an example of one of Ferric's integrated voltage regulator products in my background. These power converters have been miniaturized so that they can be placed closer to the processors they're designed to power. And this day and age, we're really talking about AI processors. They're consuming more and more power from one generation to the next. And so this integrated voltage regulation technology has become really critical to providing the power that they need, these AI processors need in order to continue pushing performance and AI capabilities.
Yes, so we're hearing all about how much power is being used by AI these days. From your experience, why is there such a demand in power now? And what can companies do to adapt?
Yeah, sure. So there are a lot of reasons why power and consumption for these AI processors is increasing at an accelerated rate. One is that the techniques for training these AI models improve with more scale. And so as you put more and more processors in parallel and have them all synchronized working on the same problem, you get more work done and you can train better AI models. And so that's why companies like OpenAI are going around setting up these huge factories for computing. But then on a individual processor basis, you have sort of the same trends, whereas you can increase the amount of resources on these processors, you can get more work done and get an improved total cost of ownership. And so if you can combine that with state-of-the-art semiconductor manufacturing technology, you can pack a ton of transistors, a ton of circuits into a very small area on your chip and drive the power consumption up to kilowatts, where the same product 10 years ago would have been consuming only a few hundred watts. So there's really like a 10x improvement on a per processor basis. And and now these products have gotten to a point where power is the main bottleneck, preventing them from achieving better performance in the next design iteration.
Mm. Now, you have created a very small chip, smaller than a dime, correct? That seems to be answering this problem. Can you share more about that?
Yeah. So, in order to provide the kind of required power to these AI processors, we need to move the systems that are controlling and converting and regulating power closer to the processor. So we have developed the set of technologies necessary to miniaturize these power converters. One of them is new ferromagnetic composite materials that allow us to shrink power inductors and include them as part of this power converter chiplet. And that's actually where we get our name, Ferric, is that we have our initial innovation is in ferromagnetic thin films that can be integrated with microelectronics to miniaturize power conversion functions. And so we developed this material. We've combined it with the rest of the microelectronics fabrication and packaging ecosystem, and that allows us to make these exceptionally dense power converters that are, uniquely poised to go and address this insatiable power demand that the latest AI processors are creating.
Wow. So, what impact do you think this is going to make as far as does this change like data centers and how they're going to be laid out?
Yeah, well, it mostly allows the processors going into those data centers to be more energy efficient and to achieve better peak performance. And so we're commonly seeing customers with current implementations of our products applied to their processors. They'll save somewhere between 5 to 10% in static power savings, and have the opportunity for more power savings through active power management. So kind of actively reducing power consumption when there's a lower workload. So on the order of 10% power savings for an entire data center can be it can lead to tens of millions of dollars in savings in electricity on an annual basis. And it can also allow that same processor, it can either operate more energy efficiently or it can operate with higher peak performance. And so you could train that latest AI model maybe 20 to 40% faster with the better peak performance available from the improved power delivery you get from the integrated voltage regulator.
Awesome. So, as we look at technology and it's evolving quickly, and we have more high performance AI clusters, what are some of the key issues business leaders still need to focus on and address moving forward?
Hmm. Well, I think it's multifaceted and there's a lot of questions that we're actively addressing relating to powering these systems. That there's um, currently it appears that there's an insatiable demand for computing power, and so we have again OpenAI and Google and Meta all making big commitments to create new computing infrastructure. As they're making those commitments, there's a race to go and develop the best systems to build and install in those facilities. We see, NVIDIA, for example, just pushing the density of their data centers more and more. And as they do that, they need to really reinvent each piece. And again, power consumption, the power delivery system is being considered there in the um, sort of active transition from 48 volt input for these data centers to 800 volt input for these data centers. So this is a consequence of the industry's push for higher levels of density. Um, so it's again, struggling to give you a specific answer aside from pretty much it seems like everything matters. Everybody's moving very fast. But generally recognize that they want to get as much compute as possible for the best cost of ownership, and certainly working within the power available to a given data center.
Looking forward to the future, are there any goals that Ferric has? And do you think that there are some key collaboration opportunities that will help y'all move forward?
Yeah, certainly. So we have we've developed and demonstrated this key technology platform for making especially dense power converters. And so now as a company, we're in the mode of developing better and better products based upon that technology, and then working closely with our customers, who are the leading AI processor developers in the world, working closely with them to integrate the technology and enable them to reap the benefits of these integrated voltage regulators. So that's really where our focus is, and it's a really exciting time because these problems are only having more significant impact and larger scale as we as a society continue to appreciate what we're getting from AI. Yeah.
Yeah, absolutely. And I think everybody knows that there should be a focus on the carbon footprint and sustainability. Do you think that there are going to be any regulations needed in this area, or are there some already that you could share?
I think as it relates to Ferric's technology, we don't anticipate any specific regulations. Our technology is all about making those AI processors more efficient and achieve better performance. So this is, a win-win in all cases where our technology is applied. I'm sure, going upstream in the power delivery system, there's a big question about where the power is coming from. Can you pull it from the grid? Do you need to generate it locally? Um, there are power transients being created by these AI factories that really create significant problems or challenges for the grid, and can create instability and shutdowns, which maybe even contributed to the downage that Amazon had earlier this morning, right? So these things certainly need to be addressed at the data center scale, and I'm sure on a regional basis, there's going to be um, more government involvement, at least, in order to make sure that our national grid is stable.
Absolutely. Well, if there was one key takeaway you could leave our audience with today, what would that be?
I think it would just be that the the intense power demands that are being created by these AI processors are best addressed with integrated voltage regulators, power converters that can be much closer to the processor and thereby provide more efficient, cleaner power supplies. So this is a really critical under the hood development that's going to allow us as an industry to continue pushing better performance and total cost of ownership. And it's a really exciting time where the industry is needing to go and adopt some really great technology. So I'm very excited, and hopefully we'll see a lot more of Ferric in the future, all future processors.
For sure. Well, thank you so much for coming on the show and sharing your insights into this topic.
Yeah, well, thank you so much for having me, Amanda. I really appreciate the time. You
And
have a
thank
great
you to our
afternoon.
audience. Stay tuned. There's more.